All right, so this is part two. It's a day late, but it's part two of the same lesson from Monday, talking about measures of spread and in ways to compare data. Um, we talked about mean absolute deviation, and we also talked about interquartile range. Again, both of those are building on the idea of a mean. Add them up and divide by the number of numbers, and then like interquartile, so quartile 1, quartile 3, median, that box plot spread. Again, that's from topics from last week. So we're kind of building slowly here. We're actually building up to the end of the school year. So if you're staying updated on all the information, the school year does end next Friday for you guys. It's the last day to submit stuff. So what I'm going to end up doing on Monday is opening everything back up. So you have a chance to go back in, correct some mistakes, try to get full credit if you can. Don't stress out too much about it. Do your best, and that's all I'm really looking for there. Do your best and give me an honest effort onto everything, and we should be okay. Thank you for your cooperation through all this. I'm going to teach one more lesson on Monday. There won't be one next Wednesday to just give you time. There'll be a question and answer session though, so if you have questions, I'll be here. But there'll be one more video on Monday, whether it be the last thing that I teach. And then Wednesday will be no video. Friday will be the last day to submit stuff, and then we'll move on from there. Okay. But today we're going into, there's only 2 example problems that we're going to do, and then I'll kind of talk about that game show problem, and then we'll wrap it up. We stopped with example 4 last time, so we're on example 5 now. And what we're actually doing here is we're learning when to use which measure of spread. So last week, we talked about, okay, when do we use the different measures of center, median or mean. Now we're talking about when do we use which measure of spread, interquartile range or mean absolute deviation. Okay, so the top of your page there has the effects and interpreting. So I'm actually going to go, so let's look at the effects first. So if you have data without outliers, the mean absolute deviation is a better measure of spread. And if you do have outliers, interquartile range is a better measure of spread. That's the same as last week. So if we have outliers, you want to use the quartiles, interquartile range, median, that kind of stuff. If you do not have outliers, all the data is semi-consistent, then the mean was better last time, so now the mean absolute deviation is better. It follows the same pattern. So if you can remember that, it can help you to remember this. Now on to the interpreting part. If they're higher, the higher the number, it means the more spread out the data is, and the less consistent. It means that from around the center, things are spread out super far. But if you have a low number on either one, both the IQR and the MAD, if that number is low, then you have consistent data. And again, it's not that one's better than the other. It's just something you need to know to interpret it. Sometimes you might be looking for inconsistent data. Sometimes you're looking for consistent. So it's not that one is better than the other, but it's just you need to know that to interpret it. So again, the higher the number, the less consistent. The lower the number, the more consistent the data. So I have 2 examples I'm going to show you. We'll start with this one up here. It's example 5 on your sheet. So go ahead and if you can look at that, follow along. So this is talking about books, the number of books that sample of students read over the summer, Class A and Class B. And each of these next 2 examples have part A and part B. It says part A says which measure of spread, the IQR, the MAD, is going to be best to compare the two sets of data. Got a visitor. So again, you kind of have to look at the stuff from above and say, do we have outliers or do we not? So let's check that out. 1, 3, 5, 7, 9. Okay, the difference between 1 and 9 is pretty big, but it's not big enough for there to be an outlier. Okay, 3 is close to 1, 7 is close to 9, 5 is right in the middle. All the data, there is no outlier in the data. If somebody read 50 books, then that would be an outlier, but there's really not an outlier here. So look at 4, 5, 5, 5, and 6. No outliers. Those are that's very consistent. So part A, which we're going to use, the mean absolute deviation, or the MAD. Why? Because there are no outliers. Okay. That was the first step, was to determine which we're going to use, and we have done that. Now, what's the next step? Compare them using the appropriate measure of spread. So compare them using whichever one you chose. We chose the MAD. Excuse me. So let's look at that. The process is the same as we talked about on Monday. So that's going to look like, got to find the mean first. And so I'll kind of do class A on this side, do B on this side. Hopefully I can fit it all in. So that would be 1 plus 3 plus 5 plus 7 plus 9 divided by 5. This 25 divided by 5. I probably actually have to do that one next. So again, you add them up, divide by the total number, so 25 over 5 is 5. That's our mean. Then we draw that table we had, which was our values, 1, 3, 5, 7, and 9. And then this middle one, we had number to subtract the mean. So this is 1 minus 5, 3 minus 5, 5 minus 5, 7 minus 5, and 9 minus 5, which is -4, -2, 0, 2, 4. Now we take the absolute value of that. So we take the positive version of that number. So 4, 2, 0, 2, 4. Oh, that last one's cut off for you over there. So 0, 2, 4. Okay. One last step here. You take these, you add them up, and you divide by the number of numbers, so 5 in this case. So I'll do that right here. So 4 plus 2 plus 0 plus 2 plus 4 divided by 5, I do believe, is 12 divided by 5, which is 2.4. Why I wrote 2.2. So full circle all around to get this number right here. This is the MAD. .4. I know I'm kind of quick there, but I'll walk you through it again. First things first, you gotta find the mean. It's mean absolute deviation. So But when you're actually solving it, it's a little bit different in the order would you go, because you kind of find the mean, kind of find the deviation, and then you find the absolute value. So find the mean by adding up all the numbers and dividing by the number of numbers. Then you take the values you had, 1, 3, 5, 7, 9, you subtract the mean from each one of them, and then you take the absolute value of that, drop the negative. If it's positive, keep the positive. Then you find the mean of those, and that's your MAD. Okay. So let me do this with class B. Again, this will be posted pretty quickly. I will leave 2.4 there. So let's do this again. Mean, which is 4 plus 5 plus 5 plus 5 plus 6 divided by 5, which is 25 divided by 5, which is 5. All right, same mean. The table's going to look a little different this time, though. So that's A. So it's 4, 5, 5, 5, 6. All right, and that's these two little bars on the ends, these little bookends mean the absolute value, a little symbol right there. So 4 minus 5, 5 minus 5. It's supposed to be a 0. So 1. Oh, you can see all that. No, you can't. That's good enough. Okay, so 1 plus 0 plus 0 plus 0 plus 1 divided by 5 is 2 divided by 5, which is, so the MAD for B is 0.4. Hopefully that corner over there, all right, it's a little 2 over 5. The mean absolute deviation for B is 0.4. Again, the lower the number, the more consistent the data, the less variability, and the less spread out everything is. So let's use that idea. Let's just look at this. So this number is obviously bigger for A, and it's more spread out. It's obviously smaller, so it is also less spread out. So compare the two sets. That's kind of what this does, and you can say in a little sentence there below, we can say class A has more, I would say maybe class A has less consistent data. That's shown with the higher MAD. Or B has more consistent data. It's shown with the lower mean absolute deviation. Something like that. Don't have to be too fancy with it. Not looking for a paragraph. Just a little verbal or written response, little explanation there. Okay. So let me get out of here. So this is example number 6. It says the data sets below show Kyla's Spanish quiz scores during the first and second semesters. We've had this set of data before. So now we got to determine, do we need to use the interquartile range or the mean absolute deviation? Let me write the values up there, and then we can decide. So this is first semester and second semester. 70, 80, 60, 65. Two, three, four, five, six, seven. Okay. So that's our data. Let's look at it. Again, we're checking for outliers. If we have an outlier, we're going to use interquartile range. If we don't, we're going to use the MAD. Okay. I see one though pretty immediately. This 10 pops out. It's not a very consistent score that she's getting. So I'm going to assume that's in this data set, that's going to be our outlier. So that means for part A, we're going to use the IQR. We've decided we're going to use the IQR. And for part B, we got to actually use it and actually find the IQR. However, there's something, the reason we're using that is because there is an outlier. All right. So for part B, you got to actually use that. And remember, to do that, the first step is to put the list in order. So I'm going to do the first semester first here. You got to put them in order from least to greatest. So 10, it's not 16, 60, 55, 70, 75, 75, 80. Okay. So again, remember what you have to do is cross it out. One at a time so we find the middle. That's our median. And now we have the lower side and the upper side. Do the same thing on both sides to find the lower quartile and the upper quartile. So cross out the first one and the last one. That leaves us with this one for Q1. Cross out that, leaves us with 75. And remember, it's Q3 minus Q1. So 75 minus 60 is 15. That's our IQR. Repeat the process for the second semester. So that's 70, 75, 80, 80, 85, 90, and 90. The process is going to repeat. So we cross the last one, first, last, find the middle. Do it on the left, do it on the right, cross those. That gives us Q1. Cross those, that gives us Q3. So now we have 90 minus 75 is 15. The IQRs are actually the same number. So if your MAD or your IQR is the same number, that means they are spread out evenly. Both sets of data are evenly spread. Now, it doesn't seem like it because the first one has a 10, but that's why we use the IQR, because that allows us to take the outlier into account without totally skewing the data. So these two sets are spread out equally. And that's shown by having the same IQR. Again, if you have questions, let me know. I was feeling pretty bad yesterday, a little better today. I'll be on my laptop, responding to emails. Let me know. Other than that, there's not much to it when it comes to interpreting it. It's just those two bubbles at the start there, where we talked about which is better with outliers and which is not. And again, if you have an outlier, you're going to want to use the IQR like we did here. If you don't, use the MAD like we did before. The bigger the number, the more variable the data. The lower the number, the less variable, more consistent. But there's the little brain teaser problem that I want to finish out the lesson with. So again, 3 doors in the game show. We got door 1, door 2, door 3. So I ask you, I'm the game show host. Okay, so pick a door, 1, 2, or 3. We'll say you pick 1. Now I say, okay, you picked 1. Now I want to make it easier on you by telling you which of the other 2 doors doesn't have the prize, $1 million. So I'm going to say door 3 doesn't have the $1 million. So that means now the $1 million is either in door 1 or door 2. Which door do you pick? Well, let me walk you through it. So when you start out, there's 3 options. That means each door has a 33% chance, or 1/3. There's a 1/3 chance that it's behind it. It's random chance. There's no way to know. You just got to pick one and go with it. But, well, let me take a step back real quick. Each one has a 33% chance. That means that there is a 2/3 chance it's in the other 2. There we go. So that's the word I was looking for. There's a 1/3 chance it's right here, 1/3 chance it's right here, 1/3 right here. However, there's a 2/3 chance that it's in one of these 2 doors. Okay. So if you pick 1, there's a 1/3 chance you got it right. There's a 2/3 chance it's on the other 2 doors. Now, if I eliminate one of these doors, this chance doesn't just go away. This probability doesn't go away. Instead, it gets added to the other door. Now, that 2/3 being the other 2 doors is now assumed by one door, the one that's left. There's still a chance that the one you picked first is right. However, the chance is greater that it's the other door. So if you're ever in a game show, or someone's doing a card trick or something, and you have 3 options, you pick one, they eliminate one of the others, it is more in your favor to switch to the other door than stay. Little brain teaser. If you want to look more into it, it's called the Monty Hall problem. I didn't want to tell you that beforehand, so you can just find the answer. There's a lot of actually debate on whether this math is right. So it's pretty cool. Give you something to do for a little bit. Again, planning on doing one more lesson on Monday. Then there won't be one on Wednesday, just to give you guys time to catch back up and make sure you're getting on top of all the other classes too. Thanks for coming today, and I'll post this as soon as I can.